So guys, today's, as I told you earlier, we're going to be finding area between curves without the use of calculators. Let's get down to business. Go ahead and copy down this slide. Try to make a loose sketch of it there. So let's do this problem. So we're doing this by hand, and the first thing that we had to do when we did it by calculator is find those points where they're intersecting, right? Same thing, we got to find the points where they're intersecting. Now, how do you do that by hand?
You set the two equations equal.
That's right. You set the equations equal. Where they are equal to each other, that's where they have a point in common. In other words, the point of intersection. So there it is. Find the points of intersection is step one, and you do that by setting the equations equal and solving. So let's do that. So I'm going to take x cubed plus 2x squared minus 5x minus 1 is equal to 3x minus 1. And now what we're going to do is we're going to move everything to one side. That's how you solve a polynomial equation. You set up everything on one side equal to 0. So let's do that. So on the right side we have 0 now, and on the left side we have x cubed plus 2x squared minus 8x. After that we factor, right? So I would start by taking out an x. And then we would reverse FOIL it or do the factoring however you're used to factoring. And then we set all those equal to 0 and solve, right? And so what do we get? So we have -4 would be this point. That's just the x value. And then 0 and then 2. Those are the three places where it's intersecting. You could find the y values as well, but we don't need to, so we're not going to. So that's the first step you're going to have to do, is find the places where they intersect. That's the new part. The old part is the part that you know how to do, but it's a pain in the butt. You got to actually solve the integral. Can I erase? All right, so next step, set up the integral. All right, so let's do this region here from this point to this point first. So for that first region, we're going from -4 to 0. And for that region, the f function is on top of the g function, so the f function comes first. So, well, when we do it by hand, you're going to need to. Yeah, so that's the first region. Now we're going to do the second region. That one is going to be from 0 to 2. And on this second region, the g is higher than the f. So this one will be written backwards from the first one. All right, so what we're going to do is we're going to combine them. Now, we haven't been doing that before because the calculator's been doing everything for us. So I'm going to have to distribute here, right, and then combine my like terms. So let's see what I get as a result of that. We have x cubed is going to stay the same because there's no cubes over here. Same thing with the 2x squared. But this negative 5x is going to combine with this 3x. And remember, it becomes a negative 3x once we distribute. So negative 5 and negative 3 makes negative 8x. And then the negative 1 will combine with this 1 over here, which after we distribute will become a plus 1, and they just cancel each other out. And we're good. Now this one over here, it's the same thing, it's just written backwards, right? So it's going to be the same thing, it's just that all the signs are going to be opposite. Okay, so on this side over here, it's going to be negative x cubed minus 2x squared plus 8x. And if you're uncomfortable with just assuming that, you could still work it out and combine your like terms. You'll see it comes out to be the same thing, just opposite signs. So there's that. I would stop there with this because I'm not actually going to do this whole problem. It's very time consuming and unnecessary because I think we've done it enough. I'm going to have you guys do it today just because it is important to practice it. A lot of students forget the next step. What's the next step? You've got to integrate it. Some people just start trying to plug the 0 and 4 in right now. You don't do that. You have to integrate first. So I'll do one more step with you guys, and then we're going to stop. So I'll erase this top one here so I have a little more space. Okay, so let's integrate here. If you integrate x cubed, you're going to add 1 to the power and divide by that value. If you integrate 2x squared, you're going to add 1 to the power and you're going to divide by that value, and so on. And that's from negative 4 to 0. Notice you could, yeah. Notice I've changed my notation now. This is my indication that I have integrated. I've gotten rid of the little integration symbol and I've put my brackets in. A lot of students kind of mix those up too. So that's why those brackets are there. That's my proof that yes, I've integrated now. All right, next one. This one's going to be the same thing, just opposite signs. So from there is where you plug in and evaluate, but I'm going to stop. Okay. Which one? Oh, yeah, you're right. Thank you. I owe you a point now. So this would be a negative, and this one's a positive. Thank you. More? Oh, goodness. Thank you. She didn't say mine. That's a fact. All right, here we go. Evaluate, you get that answer. Poof. I checked it a few times. I sure hope so. So I did it by hand, and then I did it on the calculator. I didn't get it right. So many places to get a little mistake here, right? So you found 2 already. And then I did it again. I got the calculator. So I'm pretty sure that's it. All right. So how did I answer it? Okay. There might be something wrong with me. I'm not sure. That's just how I work. So I'll be right with you, Nick. Here's 2 for you. Now, the rest of the block, I'm just going to let you guys work on these. Now, for this one on the top here, finding where they intersect is, finding where these intersect is pretty chill, but doing the integral is the pain in the butt, okay? It's where you can make a lot of mistakes and get it wrong, even though you really know what you're doing. The second one, the integral is actually much easier, but finding where they intersect is interesting. So if you don't figure it out before you leave today, the last like 5 minutes or so, I will show you how to find where they intersect. But that being said, I'm going to go ahead and let you guys just work on this. Now, whatever you don't finish, even though I'm not giving you more homework tonight, I would say finish whichever one you don't get done for homework tonight, and you can just put it in the notes as well. But I would like you to definitely finish both of them. Good practice. Let me pause the video. Finish number 2 yet? That's okay. But number 1, you should have gotten 32/3. Now for number 2, I'll show you guys how to do the first step. It's not obvious, but after that, it's actually not too bad. So the first step, you guys, we need to find where it's intersecting, right? And you do that by setting these things equal to each other. Now I've been kind of saying it to a few people, so some of you guys already know, but so how do you solve that? Well, usually you might think, well, I need to subtract them. But what's actually going to work better here is if you divide both sides by a cosine, because cosine over cosine makes 1, and sine over cosine makes tangent. And if you remember your tangent values, right, you'll know that that's pi over 4 and 5 pi over 4. And so what you're going to have is you're going to have 3 separate integrals here. The first one's going to go from 0 to pi over 4. And then the next one's going to go from pi over 4 to 5 pi over 4. And then the last one's going to go from 5 pi over 4 to the final point, which is 2 pi. Okay? You also have to kind of be aware of which one's on top. Which one is the blue one, you guys? Is that sine or cosine? True, it's the cosine, right? So the first one's cosine minus sine. The next one's sine minus cosine. The other one's cosine minus sine. So there you guys have it. I'll let you